It's yours.
Thank you, Kristian. Well, hello, everybody. Welcome again. We are here to listen to the wonderful talk of Kristian Rother about how to teach data science. Kristian is a fellow biochemist and biologist, so I consider a fellow in that sense. He has a PhD in biochemistry from HU here in Berlin, and he also has studied bioinformatics as well. And he is a Marie Curie Fellow, so that's very important. I can tell you that Kristian has been teaching Python and data science for a great bunch of people in different settings, to trainees, to academics, people like me. I had the chance to meet him as a teacher and a mentor when I was in a data science bootcamp, and I know that he's a great teacher. He was also a lead data science teacher at Spice Academy for a while, and I can only recommend him. And I don't want to be a spoiler, but I know that we are going to have fun with his talk. So thank you, Kristian.
Thank you very much, Macarena, and welcome to my talk. You want to clap, Chris? As the speaker of the first session, it's always a little bit of a duty to warm up the audience and make them hungry for the rest of the conference to come. A little bit of explanation at the very beginning. The slide reads teaching programming. It's meant teaching data science. In my head, these two things are very, very close to each other. And I want to give you some hints in my talk how you could start teaching data science if you are not a full-time teacher. But let's see who is here in the room. Normally, at the second slide, people kind of summarize their CVs. I don't like to do that because in teaching, I believe that it is all about your students. It's all about the audience. It's not that much about the teacher, even if they do the most of the talking. And I would like to do a little data visualization with you. You should see in both of the aisles bags with balloons. Please take a balloon that matches closest what you are doing. There are green ones if you are a student or graduated from a boot camp recently or are not a student yet. Blue if you are a teacher, and red if you are a data scientist, data practitioner, some other kind of expert. And then, of course, please inflate the balloon and tie it if you happen to know how that goes.
Sorry, Kristian, I have a question. What if you consider yourself a data scientist and a teacher and a student? Because I guess that as a data scientist, you are...
Do a K-nearest neighbor using the first principal component. I was anticipating that question.
Are we allowed to inflate more than one or no? Not really? No.
Okay, I start seeing quite a bit of balloons. We'll toss them in the air in a moment. I'll count to three, and then we can see who is approximately in the audience, and maybe someone is able to catch a picture, hopefully without any of the faces. So let's get the balloons in the air. 3, 2, 1. Gives an impression, doesn't it? It's not hyper accurate, but we see that most of the people in the room see themselves as data scientists or other experts, and this talk is for you. Yeah? Because the use case that I want to talk through is, what if you are an experienced data scientist and you are supposed to give, let's say, a 3-hour tutorial. I took as an example topic SQL because that is like a common denominator of many of us. Yeah, most of you probably know SQL quite well. And suddenly you find yourself in the position where you might need to teach that to other people who are maybe beginners. Why might this be difficult? Can we hear maybe some 1, 2, 3 comments? Yes, please. Being a beginner might be very far away from you. Thank you, Rachel. What else? Yes. Beginners might be used to a different vocabulary, or you are using a vocabulary that is unfamiliar to them. That's an obstacle. You agree with another one? Another. Yeah, if you just start putting on facts, then this would be boring. You need to find a use case, and I'll get to that in a moment. Thank you. There's a lot of other obstacles in teaching, but these are I think quite a few of them. And I would like to give you a little analogy that helps you to overcome these obstacles. And the statement that I like to make, the main thesis of my talk, is that teaching is a craft. Yeah, what do I mean by that? And I would like to explain that by analogy. I state that data science is a craft, or programming is a craft. When you write a program, or when you make a data science project, you have some sort of requirements that would go there in the box on the left. You implement something, a model or a piece of code, then you execute that, and you get some outcomes out of that. In teaching, it's basically the same. You sit at your desk, prepare a lesson, then you get some artifact out of that, which is your lesson, which could be exercises, code examples, slides, if you want, balloons. Then you go into the classroom and see what happens, and you might get the expected result, or you might get a different result. And in programming, it's kind of the same. So data scientists and programmers, they have tools and best practices, like using version control, for instance, or unit testing their code, or having a test and validation set to validate their model. And the question that I want you to think about is, what are the tools that professional teachers are used that make their job easier? And in this talk, I would like to bring you closer to some of those tools, so that you may have a little bit of an easier time when you find yourself preparing for a classroom. The first tool that I would like to talk about is the structure of a lesson. This is what I use to structure my lessons. And let's say we take one slice of this 3-hour SQL tutorial and say we want to spend the first 45 minutes on the create table statement. And what I do is that I have 4 sections, something for warm-up, something for theory, something for practical exercises, and then I wrap up the thing somehow. These are 4 sections. Are they evenly distributed? No, they are not. That's a detail. I thought having a circle divided into 4 equal sections looks nicer, because I don't know the exact proportions anyway. There's no perfect textbook number for that. Why is that a circle? Because the next lesson will start where the previous lesson ended. It's an iterative process, very much like when you do software development. That's also many times iterative. And in the following, I want to go through each of these 4 sections and give you one example of what one might do in that part of the lesson when you want to teach create table. And let's start with the warm-up. Can anyone name a penguin? A name of a penguin? Jim? Any other? Erasmus? Emperor penguin? Another one. Gen 2, I think that's one of those 3. I don't remember which one. Do we have 1 or 2 more? Gen 2 and Emperor are family names. Any first names? Yes. Ping pong. Awesome. Okay. Then there's also the penguins from Madagascar, if you remember. They also have names. So what's the point of this? This has nothing to do with create table. What am I doing here? Why am I talking about penguins? I want to load a CSV file that contains penguins into a database. And what I'm doing with this exercise is something that teachers call priming. Now, I'm basically warming up your brains to think about penguins. The way our brains work is that once you have done that in a lesson, it's very, very difficult to unthink the penguins. And what the teacher does is offering a way out, of course, by taking the penguin data and putting that into a database. And because your brain is warmed up for that, that goes easier than if you would just start doing create table without priming first. Like in a little bit more dry words, please compare the 3 following statements. What I want to achieve in my lesson is that the students understand the SQL create table. But this is something very difficult because I cannot open your heads afterwards and see whether you really understood this. Yeah, so that first goal is, it's not very specific and it's not testable. I can do nothing with it as a teacher. The second one is a little bit better because I can check that. Yeah, I can have the students write create table statements, and if that works, it's done. But the students they might think, why would I want to write a create table statement? This is why, as Nava said before, you need to attach that to a use case, because this is a beginner lesson. This is a very simple use case, loading a CSV file with penguins to a database. We had a big discussion yesterday with Nitin and Irena about use cases. If you teach a bigger project in data science, you might as well choose a real-world use case or at least real-world data to work with that, because that's the risk you run when you do work with balloons. So that last goal, it connects to the priming. It starts with a use case, and it is testable because you and your students, they can see everybody by themselves afterwards whether the penguins are in the database or not. Now to the theory, and this is, in my opinion, the most difficult part when you are an expert and start teaching because of this. The special agent figured it out. The teacher knows too much. This is why is this a problem? Why is it a problem when you know a lot of things? Usually the problem is that your students don't, and it's very challenging to build that bridge. In a little bit more abstraction, you have to decide what to teach. Yeah? Like, let's say this bigger sphere here is all the SQL knowledge that exists, and the smaller one is the subset that you know. It's a very bold assumption that you know, like, I don't know, 80% of. Definitely not describes not my SQL knowledge, but you get the idea. Yeah. Now, you have several options. Do you try to cover a little bit of everything? then your lesson will become very, very crammed with theory and probably boring and difficult to listen to. Or the alternative would be to pick up some small subtopic and do a deep dive on that. That is very problematic as well, because your students won't know where to put that knowledge. And there is a third strategy that I recommend that is not super easy to implement, but this is the best practice that I have learned from my teacher trainers. That is that you select a handful of concepts and lay them out as stepping stones. Here the concepts that I put here in the diagram, they are like they are selected based on my own expertise about create table. Having create table, a table has columns, a column has a data type, and then I also put in the copy statement because you need copy to get the CSV file in. And your students can use these as stepping stones to actually solve the problem and connect it to the goal. There is a textbook number that is 7 plus minus 2, which is the number of concepts that a single lesson can take. So I would be a little bit careful with that. That number was developed somewhere in the first half of the last century when there were no computers, and it definitely is less than that when you do online teaching. So when I do an online lesson, I rather aim for something like 5 plus minus 2, and then in a class where there are laptops, it's probably 6 plus minus 2, because the technology gets in the way a little bit, as all of us probably have experienced recently. Now, one might ask, okay, yeah, but what about the space in between these concepts? There is a lot of space in between. So things that you need to leave out, that you're skipping over when you focus on these few concepts. Don't worry, teachers do that all the time. They leave out stuff. The human brain is fortunately very, very good at filling in gaps. It has a remarkable auto-completion feature. And if you're working with intelligent people, which I expect anyone teaching data science does by default, then this will fix itself over time. That's the theory part. So I would say that having some description like that, you can make a diagram out of that, show it to your students and say, hey, these are the main items we are covering in this 45-minute lessons, and here's how they are connected. This creates a backbone for your entire session. You can use this to introduce the topic. You can use it to summarize the topic. Your students can use this to ask questions. And in your next lesson, you can connect more stuff to it, because your students will have organized these things efficiently in their brain in the meantime. So for instance, if in my next lesson I want to go deeper and cover, all kinds of different constraints, then I can do that. The students already know where to put that. And this is a very powerful mechanism to organize large amounts of knowledge. Now, what about exercises? At some point in a data science lesson, you will probably have to deal with code, where code can be anything that is executed by a computer. And this is a little bit more difficult, because code is very, very brittle. You get one character wrong and it falls apart. So how to teach people to do coding, actually? Let's say you have a code example like this. You can prepare that, and you may want to make an exercise out of that, or actually teach people how to write this. In my opinion, any code example can be made an exercise, and this is my main takeaway from this session. The problem that you're solving here is, if you show people this piece of code on a slide, and then it's gone, or even if they copy-paste it somewhere into their notebooks or their PSQL terminal or whatever, it's kind of boring. They don't learn anything if they take something that's already working. On the other hand, if you give them nothing, they get lost. Yeah, so how can you fix that? One approach that I propose is that you basically give them half a solution. Example number one. Take the working coding example and then build gaps into it. Leave out stuff. Yeah, and if you work with beginners, you can ask them, yeah, okay, here we have 1, 2, 3, 4, 5 words. They need to go into the gaps. Yeah, which goes where? Intelligent people can figure that out, especially if you let them collaborate. This is something that you could use to introduce something for the first time, if they haven't seen anything like that before. If you want to make a recap out of that, you could leave out the cues at the bottom, and it becomes a tiny bit more difficult. Next level would be to give them code that is almost working. Yeah, in computing, almost working means it's not working at all, of course, because it's buggy. Does anyone spot a bug in this? Yes. Exits, it should be exists. Semicolon at the end is missing. Sorry, Rachel? It should be a varchar 10 and not a text 10. The bracket 10 is swapped. I think there was another one. Oh, the starting bracket is missing, yes. The body mass is smaller than penguins. Most penguins are below 10 kilograms, unless, well, it's funny to imagine, sorry. I don't know whether that was an appropriate comment. But you get the idea. Debugging code is part of the skill set, and you might start with that right away. And eventually, this will put you in a situation where you can leave most of the things. Like this is reduced to the maximum, where you have only the create table left over, and you give them a hint. Okay, it starts with create table, but I'm not going to tell you what to put after that. Yeah? So a setup of a longer lesson could be like, you start with a simple exercise that is very easy, then do another table with a slightly more complicated one that they maybe have to debug, and then you lead them to the point where they only see the CSV file and the create table and figure out the rest by themselves. That is the practical part. I think this is where your students really grow and acquire new skills and make them their own. And at some point, your lesson is going to end. How to close that effectively? This is not that easy. I think this is the part that I struggle with the most, because when you plan the end of your lesson, you don't know what is happening between the start and the end. There's a lot of ifs. Yeah, for instance, your timing might be completely off. You might get interesting questions, or maybe your students don't want to say anything, or someone messed up, or half the class messed up their installation, and you're busy installing Postgres with them. Has happened to me and many of my teacher colleagues. What I recommend as a kind of fail-safe strategy is to have a few questions in stock. For a 45-minute lesson, 3 questions is completely enough. Yeah, for a 90-minute lesson, it could be 5. Yeah. The questions can be different types of questions, like how does the actual solution look like? How did your create table statement look like? How does the copy statement look like? What problems did you run into? But then you could also have a few deeper questions in mind, like does every table need a primary key? This is a good question. I think I got this from students a couple of times. And if they ask these things by themselves, great. If they don't, give them the question, let them think about it for 1 or 2 minutes, and then you can have more or less educated discussion. The last question is a type of question that encourages them to think out of the box and connect what they just learned to other parts of their brain, like advantages, disadvantages between SQL and Python. And it may happen if you have these questions that you are not going to use them because other interesting stuff is happening in your lesson, but then you can use them in the next lesson as a warm-up, or you still have them as a backup strategy and feel safe. To wrap things up, we've seen a couple of tools that teachers can use. First of all, this lesson structure as such, then starting with a problem, because that drives your entire lesson. When you do theory, less is more. You don't have to overwhelm them with content. What we have seen here on these slides is enough to power an entire lesson on SQL Create Table. Any code can be made an exercise. You can create exercises of very different difficulty from the same code. And if you have questions prepared, this is a great way to wrap up a session unless something else comes in the way. That's what I wanted to give you as a hint. In case you are thinking about giving a workshop or a tutorial somewhere, whether it's next year's Data Lift Summit, and if you have never done teaching before, try it. It's something that's very that you can get into. I'm happy to share advice and help with that. I've got a section on my homepage on teaching where I wrote a couple more of practical tools that I've been using in my teaching. You're welcome to try it out. Thank you for your attention, and we have hopefully time for questions.
Thank you very much, Kristian. It was a great talk. Now I see bugs in a different way. I mean, I can even use them for teaching, right? Any other time. So it's time for questions. Yes, I'm the runner here as well.
Thank you. I just have a question. How do you deal with different levels of expertise in the audience? For example, you have a senior developer, and in the team there's a junior, someone who's there for 6 months, someone who's completely new, but all of them need to understand a topic.
Yeah. So part of the answer is to have these coding exercises at different levels ready. Yeah, because an experienced person sees the easiest level exercise, they might be finished with this in 2 minutes and say easy, okay, let's do the next thing. That is one part of the answer. Like, you can prepare for that, because I would say this is the usual case in most classes. The other thing is, please drop the expectation of getting everybody to the same level at the end of the day. In my opinion, in teaching something like coding, this is a bit futile. My aim when I teach is that everybody by the end of the day, by the end of the week, knows more about the subject than they did before. But it does mean a different thing for the experienced and the beginner person in the room.
More questions?
Do you have a tip how to handle people that think they know quite a lot, but they are actually they read some keywords and buzzwords and are missing some of the basics? And I'm thinking about data science. So,
yes, I do. The first thing that pops up in my mind is I occasionally have to deal with participants where this kind of behavior gets in the way. Many times these are super nice persons outside of the classroom, but sometimes if you have someone that comes that comes to you and wants to tell you how to teach the thing. This really sucks, yeah, and it counts as disruptive behavior in my end. What I strongly recommend, especially if you're part of an organization that regularly does teaching things like that, is to have a code of conduct that the students commit to before they engage in something like that, and have a path of escalation, hoping that you never have to use it.
More questions. Well, I have another one. I will benefit from being the moderator and ask a question. What are the extra challenges that you face in online teaching compared to on-site?
Two things.
And what to do about them?
Okay, so that's a three-part answer. Part one is, compared to classroom teaching, I believe online teaching sucks. Yeah, point two is because I cannot use balloons and I don't have a whiteboard. Yeah, that kind of summarizes it. Part three of the answer is, I've spent most of last week to write an online teaching survival guide. It's on GitHub. I haven't gone public with it because I have to coordinate with the person who asked me to create this thing, but I insisted putting that under a Creative Commons license. So I would expect that these things will appear on my LinkedIn timeline before too long.
Great. We'll keep an eye.
So there are small safety strategies that you can do and little things that encourage your people to talk.
Great. More questions? Another one there.
So you talked about, how to prepare for a lesson. Do you have something to say about the emotional intelligence and the patience that's needed by a teacher, or expected from a teacher?
I would say that if you okay, let me exaggerate a little bit. If you come into some place and give a one-day tutorial on something, yeah, let's say you give a one-day course on advanced SQL, because I get the impression that is more like you are more with the advanced people. You don't need very much emotional intelligence, because usually your students in data science, they really want to learn the thing. They bring a strong intrinsic motivation. That might be different in school, Martin. Yeah? However, if you do something that takes longer, like let's say anything from a week to a 3-month boot camp, things are very, very much different. Yeah, because people move in different directions. They figure out that they don't get along with each other well. They get frustrated. They start thinking about questions like, will I find a job after this? Yeah, as a teacher, you may think, this has nothing to do with my lesson, but for the students, it's really important. So they get nervous, and as a teacher, it's your problem anyway. Yeah, so you do need emotional intelligence and some strategies to deal with that kind of stuff. And there's group management techniques for that. If I were to put in a single tool that is also useful in a normal development environment to leave off a little bit of steam every now and then please check out the lean coffee method, because that allows everybody to talk about things that matter to them at a given moment. Thank you, Nitin, for the question.
There is time for one last question. I'm sure there will be one. Okay, if not, that's it. Thank you, Kristian. Thank you very much. Thank you for being here.